Hi, everyone. Welcome to DOP229, automating app upgrades and maintenance using our newly released feature. Using our newly released feature, Amazon Q's code transformation feature. I am Vishwesh Sahasravade. I am the principal product manager working on this feature.
Hello, everyone. I'm Jash Chabra. I'm the senior SDM running the Q Transform team, engineering side. I'm very excited to talk to you about the new feature we released. There's a lot to come ahead, so let's get started.
Yeah. So let's go over what we'll be covering today. We talk a bit briefly about why application upgrades is a challenge. You kind of try to balance updating and maintaining and modernizing your applications with actually doing productive business work. And those things get in conflict, and those leads to issues, which is where some sort of automation, some sort of improvement can help you guys a lot in maintaining your applications as well as achieving your business productivity goals. So how does Amazon Q code transformation help you there? We'll provide an overview of what this does, what is today available, and what is coming next, as well as go a little bit under the covers of how we achieve this, how working with Amazon scale of 17 years of experience, building and upgrading applications, how that helps build this kind of a capability that brings in the GenAI capabilities as well as some of our knowledge bases, et cetera, and provides a better end-to-end experience. We'll also go over some specific examples of the Java upgrades capability that we have today and how it makes changes, what kind of different things it can do, as well as go over an actual demo of a live app upgrade. And then finally, we'll cover some of the future enhancements that are coming down the road. OK? So what is the challenge with application upgrades? You have, for enterprises that have been building applications for a while, as well as new companies building new applications, you start off with a set of state-of-the-art versions or languages that you need to support. And eventually, what happens is you have a well-working application, but then new versions come out of the language. New features are available. You start losing support for the actual versions that are available. And this whole process becomes tedious and time-consuming to kind of do application upgrades for two reasons. One is a lot of these new features, you need to, first of all, understand what's new, what's relevant, what needs to be updated, what could be updated, how can it get how can your applications benefit from it, as well as many of these applications have been developed by other teams, other developers. We don't have that expertise anymore. So you need to first understand that code base itself. So you have those two different conflicting things, which kind of delays a lot of these application upgrades. However, these are things that can't be skipped many times. You have versions coming end of support. For example, in Java, you have a 2-year train of long-term support versions. So every time you have to go to the newest version. Even if you don't, the previous versions lose support after a bit. So you don't even get security updates after a bit. So you have to kind of keep doing that. However, developers, as I know a few of them, and I have been before, and these are not the most productive tasks you want to work towards. These are essential tasks. These are important tasks. These are hard tasks, actually. But they also compete with delivering your business objectives. In your sprint cycle, do you prioritize getting that dependency version updated, or do you want to ship the new API feature? It's always going to be a conflict. It's always going to be hard. And what happens is these upgrades keep stacking up. So that becomes even worse, because now more and more of your applications go out of cycle. Your technical debt keeps increasing. You are prioritizing newer features, but you keep having this whole stack that needs to be updated. Well, you end up with security campaigns. You end up with upgrade campaigns. And then you have these top-down requirements, which just forces you to work on these features. Not a great state to be in, right? So therefore, what can we do in this to help with this situation? What is interesting is that what we learn from working with our own developers, talking to customers, et cetera, is that the application upgrades are challenging, as I said, for two reasons. One is that you have to work on an existing code base, which you might not be an expert in. Somebody else might have developed it. First of all, before you even start updating different capabilities, features of this, you need to have an understanding of what the code base does. So a lot of time is spent in researching that, researching your own code base, as well as researching what does this new Java version provide, what is absolutely required in terms of features that are needed to be changed, deprecated features. Then you have a bunch of dependencies that you use, test frameworks, other kinds of frameworks that you need to upgrade to. They have their own cycle of updating, and they have many times introducing breaking changes, which means you need to make updates in your configuration files, but as well as go deeper into your code base and figure out where do you use that dependency, or where do you have to have this new feature, replace an old feature, use the new feature. How do you do that? Typical developer cycle is you do some research on one thing, you try and write, you try and get it building, figure out what's breaking, go to the next feature, go fix that issue, go through this whole cycle again and again. Every time you spend a lot of time on researching, which is where like the knowledge bases of LLMs and other kind of technologies can help a lot. It can not only understand your code base, as well as have a better understanding of the language versions itself, so you can kind of use those technologies to kind of speed up that portion. But we go beyond that, because we can do a better job of iterating through this whole cycle with our automation. So we can have iteratively go and fix build issues and fix one by one the next issue. So within a certain period of time, in minutes to hours, you can have your entire application upgraded within a single click. We'll go a lot more detail into how that happens with our Java upgrades in our demo, as well as some of the descriptions later on. So how does Q code transformation work? Essentially, as I said, like we have this application, we have a knowledge base, we have understanding of what features are there. How do we kind of make this work? Well, we try to design as simple an experience for developers as we expect, making it as easy as possible where you work and where you can use it. So right within our Amazon Q plus Code Whisperer toolkit plugin, you can use this transformation feature either directly clicking on transform or through the chat interface, through the Q chat interface. You click on transform for an eligible application. Today it is Java 8 and Java 11. We will have more versions and more languages coming soon. What happens is we upload the code into a secure build environment in the cloud. That helps us analyze the code. We start off with a deeper analysis, not just of what the code does, as well as what are the requirements from the specific versions. You can select Java 17 today. We'll have more versions coming soon. But we'll look at, for example, what is the delta between Java 8 and Java 17 that is relevant here. If you have Java 11 and Java 17, what is the delta that we need to mandatorily update? We do those updates automatically through your entire code base. We then securely build that code. We see what the errors are, and then we iterate through those errors. So exactly the process that a developer follows, except it's all automated end to end. The advantages of this are obviously that a knowledge base, an LLM, et cetera, can help us analyze the code faster, can provide the context of an application that might not be there for a developer. So all that time of research is now offloaded to our automation system, as well as this entire knowledge base that is available through Stack Overflow, through other types of resources that the developer would have to do when they try to fix those build errors. Well, this is part of the LLM already, so we can kind of leverage that and do the entire automation and provide you with a fully built, secure, and tested code. We actually take the existing tests that are there in your application code base and validate that those tests also work. Actually, that helps us improve our code as we fix more errors, make sure that unit tests are passing again. What you will receive back is actually just a patch file or a diff that you can apply through your IDE interface. So the developers remain in full control of what kind of features they want to add. Nothing changes on their machine. They can choose what to change, whether they want to accept all the changes or whether they want to make modifications to the changes, whatever is suitable, and be able to do the remaining integration testing and push it to production after the fact. Knowing that this is already a validated code, it already works with Java 17 automatically, it already has the new features integrated, it has the dependencies updated, everything is working as expected. As I said, this process, in our experience, takes from days to weeks, depending on how complicated an application is for a developer. A lot of time spending on research, a lot of time iterating on those loops of going through that end-to-end process. In our experience, we have been able to do it within minutes for most applications, at less than an hour usually for even larger applications. Depending on how big your application is, it would take different amounts of time. But the fact is that once you submit the code, it is just, you can do your other work while waiting for this to finish without any needing for a lot of interactivity, on a lot of back and forth on how to fix issues, etc. So what does that help us achieve, basically? You can now obviously enhance your productivity because your Java upgrades are now one click. Not only does this help with achieving parity, etc., with the security requirements, but also you get a lot of performance features enhancement automatically because of new versions. And obviously, you can further fine-tune depending on your application needs and achieve further enhancements. That obviously leads to a better security posture in terms of making sure you are compliant with new versions. You have, well, basically, you can now tell your security campaigns that your work is done, your critical work is done, and don't have to kind of go back to working on more productive things, on building new features. OK, so that's a high-level overview of what code transformation does and how we believe it can help you accelerate your productivity, taking away a lot of the undifferentiated work that is essential, but could be automated, and we hope and we believe that we can achieve a lot more productivity gains for you by using this feature. So that's a high-level overview. How does it work actually in practice? I'll hand off to my colleague, Jas, who can go a little bit more detail about what's under the covers.
Thanks, Vishwesh. So as you heard from Vishwesh, Amazon Q code transformation has been built to solve a lot of challenges that we ourselves also saw with Java upgrades, with other kind of framework upgrades, etc. And now I'm going to talk a little bit about behind the scenes, how it works. When we were building the Q code transformation product, we tried multiple techniques. We tried some program analysis techniques. We tried rule-based upgrades. We tried LLM techniques. We tried some other AI techniques. And what we found is what worked best is a combination of these techniques, depending on what aspect of our workflow stage, of our upgrade stage we are talking about, or what aspect of our system we are talking about. So I'm going to give you a little bit of a view of that. So this picture kind of shows a 50,000-foot view of our system. As you can see, the way our workflow works is we take your source code, and the very first thing we do is we build and test the application as it is. So we want to make sure that we can build it with the Java version that you have. So today we support Java 8 and 11 upgrades to 17, so we might build it with 8 or 11, depending on which Java version your application is using. Once we are able to make sure that the build and test is done, then we go on to the next part of the workflow. One thing I do want to point out here is that when we take your source code and are running it through this workflow, we don't store your code. We just take it, run it through the workflow, and at the end of it, the code is gone. That's one aspect. Second is we do support CMK, which is customer managed keys. So even in temporary storage, as we are building and testing the code, we have to kind of keep it in temporary storage for a little while we are working on the code. Even there, you have full control over what key we use to encrypt while it's in temporary storage. And at the end of it, of course, we delete it. So you have complete control over our access to the code while we are working on the code. Okay. So once we build and test, then our workflow jumps in. Our workflow is composed of like 2-3 different steps, which I'm going to walk through. But first, I want to talk about a knowledge base. The reason I want to talk about the knowledge base is it's the core piece on which all the other steps of the workflow are dependent on. And this knowledge base, to develop it, again, we had to use a combination of techniques. No single technique worked for us. So we used simple rule-based engines to go and mine various open source repositories, various open source applications which may have already been upgraded from 8 to 17, 11 to 17, and our internal applications, which we have a huge number, of course, because in Amazon, we use Java a lot. And we were able to mine our own applications also, which had been upgraded from 8 to 17 or 11 to 17. So combination of that allowed us to build up knowledge base. The knowledge base itself, we ended up using, like I was mentioning, rule-based techniques, but we also ended up mining and parsing some of the data using LLMs to be able to extract the knowledge in a format that our rest of the system could use. Okay. So let me go through example of what a knowledge base can do. Now, I'm not going to show you the internals of how we store the knowledge base and how it looks like, but I'm going to walk you through how we use the knowledge base or what kind of aspects the knowledge base helps with. So this is one example where we need to upgrade a dependency, Jackson Core. So our knowledge base might say something like Jackson Core range of library version 2.x to 2.y needs to be upgraded to 2.12.5 or some other version. And based on that knowledge base, then we can apply this upgrade automatically using our engine. So that's one example of knowledge base. Another type of knowledge base example where we use the knowledge base is to fix errors. So many times, even after you've done the upgrade, you might run into errors that have to be fixed. And there again, knowledge base is helpful, where the knowledge base can tell us, hey, if you run into this error, these are the examples of how somebody else had fixed them in the past. And these examples can direct our LLMs or our other models in the right direction to fix these errors. So this picture kind of shows our overall workflow. So now I'm going to walk through the workflow itself, the details of the workflow. Now I talked about the knowledge base and how critical is it to our workflow. And this knowledge base itself took a lot of mining. We probably, I would guess, mined about 200,000 plus applications to build this knowledge base, which itself is in a big task in itself. And we keep on extending the knowledge base with more and more mining, more applications, as many applications as we can get our hands on. And it's not just applications. There are other sources also we use for mining this database. Anyway, so the first step, after we take the source code, we build and test with the Java version that your application was originally built in. Once that's done, then we start applying the knowledge base. And again, knowledge base application itself takes a combination of techniques. We, of course, have rule-based systems or program analysis-based system where those could do simple things like change one library version to another. And we have other techniques to do code changes, including LLM-based techniques, where we apply the knowledge base. One other unique aspect of our system is it's not easy to figure out what parts of knowledge base to apply on your application. So just figuring that out, just because we have this vast amount of knowledge in our data in our knowledge base doesn't mean that we can just randomly start applying everything, right? So just figuring out what to apply itself takes a set of techniques where we may have to decide, hey, for this application, given these combination of dependencies, the way the code is written, we need to go down this path. When I say path, what I mean is we may need to upgrade these dependencies, and based on that, we may need to change these code paths, etc. But once we apply that knowledge base, and after that, we go to the next step of the workflow. But let me first give you an example of what is an application of knowledge base. This is very similar to what I talked about before, where one of the big parts of our knowledge base is just understanding the library versions, which are recommended, which library version to upgrade from what. And there, again, we use static tools for simple scenarios, such as the one shown here. But in many cases, we do have complex things where we have to change annotation in the code because of the library changes, or even upgrade some other libraries depending on the library changes we already did, or change the code because the API signature itself in library has changed. So that requires more complex techniques than applying simple rule-based system, simple rule-based things like using static tools like this example. So now that we have gone through applying the knowledge base, a lot of time just applying the knowledge base may be sufficient. And we may already have upgraded the application. And the way we test that is we'll again run the application using Java 17, which is the version we are upgrading to. And if everything is fine, perfect, then we can give you the final result. But in pretty large percentage of cases, that's not sufficient. What we found is even after we have done all the changes, applied the knowledge base, there may be build or even sometimes unit test errors. So the unit tests we run, maybe one or two of them are failing. And there, we have a loop going on, what we call the fix error loop here. Here, LLM really comes into play, plays a very big role here. But it's not as simple as providing the LLM the error and the code, related code, and asking, hey, LLM, can you fix it? It doesn't work. We tried that. So what, as you can see, we also use our knowledge base in this scenario. So we have collected, again, by upgrading internal apps, by upgrading all sorts of open source apps, we have collected huge amount of these errors that we run into, figured out what the solutions are, again, in an automated way by mining other knowledge bases, even mining some of the internet stuff. And that knowledge base then helps us direct the LLM in the right direction. So when we ask LLM to fix an error, not only are we saying, of course, we have some unique prompting techniques, the right prompting techniques, but also we provide the right context, which is very, very important for LLMs to do the right thing. And of course, I'm kind of somewhat simplifying the loop itself because it's not as simple as fix the error and then fix the next error. There is sometimes it's almost like a search space that we have to do. And internally, we have some techniques to go through the search space, which error to fix first, what error to fix next, and so on. So that's also some things we kind of look into. Let me give you some example of how the error fixing works. So in this example, the error, once we have upgraded the whole application, once we have applied all the knowledge base, the error that shows up is that we have a java.io unsupported encoding exception that's never thrown in the body of corresponding tag statement. So we give examples of this to LLM, we give this code, and LLM is able to fix it and output the fixed code. And then we can essentially move on to fixing the next error if there are any left. All right, so I walked through a 50,000 level view of how the overall system works. We took the source code, we built and test using the Java version that you built your application on. We applied a knowledge base, but as we saw, that's not a lot of times sufficient. We may still run into errors either in build or in unit test that we have to fix, maybe because the API signature changed, maybe because something else changed that was not in our knowledge base. And then we work with LLM to fix these errors. And at the end of it, we provide you a patch file, which is the upgraded code that you can apply to your application and essentially get a fully upgraded application after that. OK, so now I'm going to switch to the demo. All right. So the demo itself is going to take a little while to run. So I'm going to kick it off, and then we'll switch to a window where I've already upgraded the application. So before you start using our product, in the IDE, and we support IntelliJ and VS Code, in the IDE, you need to install AWS Toolkit plugin. And under the AWS Toolkit plugin, you'll see a transform button. And that transform button is what you need to use, or you can also use the chat window in which you can say /transform. That's the other option. And either one of these options you choose, you can start your transformation. One of the other things I want to point out is that we do need you to sign up with IDC, because we use Identity Center credentials here, and your admin may actually have to enable the queue preview features, because preview features are not available by default, and admin may have to go in the console and enable these features. But once these features are enabled, in this case, of course, I've already enabled everything and I'm ready to go, I can click on the transform button to get it started. And you'll see a pop-up coming up here. And right now, the pop-up only gives you one option of essentially Java 17, but in future, we are working on other kind of upgrades, etc. And I'll kick off the transformation. So when the transformation kicks off, what happens is it first makes sure, again, the same steps I've walked through are happening behind the scenes, where we are building the application, then we'll try to apply the knowledge base, and then we'll try to fix errors if there are any. Since this is going to take quite a while, in this case, it takes about 10 minutes for this application, I'm going to switch to another window where I have already upgraded the application. So once you finish the upgrade of the application, you see the status right here in what we call the Transformation Hub. And you can always switch to it by going to the AWS Toolkit and clicking on Transformation Hub. And here, within this, one of the aspects is looking at, we generate a plan first. So let me go to the plan. So if you look at the plan is very similar to what I mentioned earlier, and which is essentially we upgrade your dependencies in code, applying a knowledge base. Then we build in Java 17 and see if there are any errors, and we fix those errors. And as I kind of showed you in the workflow, we might do this iteration like multiple times. And in this application, actually, there are multiple iterations, and that's why it's going to take about 10 minutes for the whole job to finish, because build and test cycles, multiple build and test cycles take time. Once we run through the plan, at the end of it, you'll also see a transformation summary, which kind of talks about what we did. So for example, in this case, the system changed 3 files. One, the POM, which is, of course, for upgrading any dependencies, etc., and then some other code files. And there is also, after we are done, one of the things I want to point out is your project likely already it has selected the JDK 1.8 because you are building in JDK 1.8. So you would need to go in the IDE settings and change it to use JDK 17 to be able to build in JDK 17. And so that's summarized right here. And the way you look at what the upgrade results we gave you is through the diff. So that's what you have to apply on your project to be able to build in Java 17. This is the diff viewer built into IntelliJ that we use here in this example. So if I click on any one of these files, for example, this one, you can see the code changes. Like we changed some of the imports. We changed some of the annotations to be upgraded because the annotations don't work with old Java 17 code anymore. And we changed some other pieces of code here. Okay. So, all right. So yeah, so this is still, as you can see, going on. And in this window on bottom right is all the updates are coming in, what we are doing. So you kind of get a view of what is happening in the back end behind the scenes. Okay, I'm going to switch back to the presentation. All right, so we did a demo, and we went through the whole workflow. And it's very easy to use, as you can see. You just click a button, and at the end of it, the whole process has gone through, and we get a final result. So I'll give you a couple more examples of upgrades of specifically of code, the kind of things we fix. So in this example, what it shows is that we applied all the knowledge base, and we ran into some compilation error. And the compilation error was that we could not find the system, I mean, the compiler could not find the method, the symbol secure. So we passed the knowledge to LLM, we asked LLM to fix it, and it comes out with the corrected code where it adds this secure equals false, and we can move forward with the upgrade. At that point, we are able to successfully finish the upgrade. We may have had to fix other errors too. And there's another example which is a little complex, can get a little complex, which we do. So sometimes when you upgrade the code from 8 to 17, you may also have to upgrade from Java Unit 4 to Java Unit 5. At that time, all the annotations might have to be changed, like some of the other accessors might have to be changed. For example, here public was removed. So all those changes we automatically do. And I can tell you from personal experience that this itself and these kind of things save huge amount of time. I remember before we had this tool in my team, one of my teams, one engineer was given a very large application where he had to move from JUnit 4 to JUnit 5. And it took almost a week or so of work, because it was a very large application, to change all the code, test it, make sure everything is working fine, fix all the errors. A lot of it was also research and understanding what it takes to move from JUnit 4 to 5. Because nobody is doing it every day. So when you want to do this upgrade, only then you go and look up the knowledge base, so you forget about it after a month or two. So if you need to do it again, you look up again. And that's one of the aspects that we really help with here, which is developers don't have to worry about remembering all this. They just tell our system, and we can do the upgrade for you. All right. So I talked about how the system works, what's the behind-the-scenes view of the system, gave you a 50,000 view, gave you a view of our workflow, how we use a combination of techniques. But of course, this is a preview version, the first version, so we do have certain limitations, which we do plan to fix as we build subsequent versions of the product. So currently, our knowledge base primarily knows about open source packages. That brings in some limitations, which is if your application is dependent on other internal packages, we don't know how to upgrade them yet, right? So what we'll do in that case is we'll upgrade our application all the way with upgrading open source packages, but there may still be certain dependencies which are your own internal ones that we haven't upgraded, and you may have to upgrade them yourself. Now, a lot of times what we find is that maybe dependencies are already Java 17 compatible, in which case it's okay, but if they're not, then you may have to manually change that. Now, we are working on ways to fix that by learning from your code base in future, where we may, like similar to what Code Whisperer customizations does, where we can take your code, learn from it, and make the code generation more custom to you. We plan to add similar feature here, where we can take your code, analyze it, build a knowledge base specific to your code, and essentially be able to upgrade even first-party dependencies, which is your internal dependencies. So that's a current limitation. All right, so that brings me to end of the presentation. So to summarize, right, we talked about Amazon Q, we talked about how it can help you, we talked about how it works. Our goal really is to help take all the effort away from maintaining and upgrading and patching and keeping your application up to date, which is really in some ways, the least value add for a developer. I mean, it's very, don't get me wrong, it is required, it's needed, it's hugely valuable, but developers' time is better spent on building new features, delivering new customer value. So we want to take that aspect, which is the maintenance, upgrade, patching aspect, all that burden away from you, so that you as a developer or your team can focus on really delivering features for the customers, where you can add the most value, grow your business. And with this product's help, we essentially help you do this and enhance your productivity with Java upgrades as a step one, but that's not where we're going to stop. Of course, this stuff is very important to keep your security posture good, because if your application still has older versions of libraries, older versions of Java, etc., you may not be getting the latest security patches, you may not be performing at the level, I mean, your application may not be performing at the level it should, because with new upgrades, performance improvements are also available. We also pre-announced, and this is coming soon, is helping your applications upgrade from Windows .NET to .NET Core on Linux. So that's going to come soon. In fact, we internally also used this tool before we launched. As I said, we have also mined internal and external applications, but we also wanted to make sure that the system actually works for our own internal applications. And we were able to migrate 1,000+ Java apps in just basically a couple days, with just on an average taking like 10 minutes on each application, but of course some large applications took much longer. Now typically, very, very conservatively, each one of those applications would have taken 2 to 3 days. Frankly, from my experience, anything takes about a week, but conservatively, it would have taken 2 to 3 days. So doing 1,000 applications means almost 10 years of SDE effort we saved with just within, we got the equivalent of that in just 2 days. Right. Okay. So that brings me to end of the presentation. Thank you.